Hello everyone. Today again we're going to continue doing that 2023 IIT JEE Advanced Physics Paper 1. Today we'll do section 2 of that problem, and we're not just giving you a solution, but we are trying to give you a strategy for solving the problem, and then how to take the exam. Sometimes it's better to skip over problems and come back to it later and things like that. Those kinds of strategy I'm discussing also. Okay, so here is section 2, and if you look at the instruction for section 2 here, it tells you there are 4 answers to each problem and only one of them is correct. And so if you get the correct answer, you get a +3, and if you don't answer the question, it's 0, and it's a -1 for all of the, marking a wrong answer. Okay, so this is much better than section 1, where you had 4 parts, 4 choices, and anyone could be right, and if you, by whatever mistake you choose a wrong answer, and then you got a negative mark of -2. This one is really negative mark is I consider fair, because here you definitely you can you have for instance, this question has 2 values you have to find, and you can use one of the values as found it, and then you can try to check with the second value, so that the both values will be wrong, like A and B. The V is the same, but omega is different, so both values will be turn out wrong. For you is much lower probability. Okay, all right, let's do question 4. So what is this question? Question 4 is let me move this up and draw some picture to get a sense of question 4. And by the way, this has to be done really very short period, 2 or 3 minutes, so maybe 1 minute to read the question and like 2 minutes to do the problem. You should definitely I like to read the problem and say this is I'm looking from the top, and so this is the horizontal table, and maybe the table is there is a bar of mass m length L, and one end the bar is pivoted, so this part is pivoted, so it can rotate about it, and this is the halfway mark. So this is L/2 over here, L/2, but the pivot is here, so it can rotate about here, and there's no friction for its rotation, and a small mass m is going to come at some speed 5 meter per second. I guess you can't read that, so 5 meter per second, 5 meter per second, and little m, and then it's going to collide. So this is like paper before collides the situation, and after that, and this is omega is 0, it's not rotating right now, but after collision this thing goes this with the speed v exactly back, and this thing rotates with some omega. So this is after situation. So this is a collision problem, but you can see there is a external force involved here, and between here and here, best to set up angular momentum conservation. So one principle will be angular momentum conservation. And then then there is a the collision elastic. So number 2 principle will be kinetic energy conservation, and this has to do with Sin's elastics. So I need to set 2 equations, but over here, if you want to do angular momentum conservation, you need to know how to if this was the axis coming out like that, then what is the angular momentum of this ball here before the collision? And of course, angular momentum of this will be 0. Over here, the same way, the axis is this way. Excuse me. Then we would like to know what is the angular momentum conservation formula for even the bar about this axis. So angular momentum for this for a mass, if I go perpendicular, this is the path, and I draw a perpendicular to it. So it comes over here. So that distance, this distance is r perp. So mv r perp will be the formula for the particle. For formula for bar will be, say, momentum inertia I about this point. So I about that, I about the edge point O, and omega. So you can say if tendency to rotate this way will be plus, then this is also tendency to rotate that way. So over here, this ball is going backwards, so this will be negative momentum inertia, and this will be positive angular momentum. Okay, and this will be positive angular momentum. So and how about the kinetic energy formula? Of course, it's going to be half mv squared for the particle, and for this thing will be half IO omega squared. So we have all the formulas, and we can just basically doing the algebra, right? So let's do the algebra out. So let's see. So for angular momentum, you have before you just have a m is mass is 0.1, so 0.1 kilogram. V is 5, and L was 0.2, so it's got 0.1. So this is like a 10 to the minus 2. So this is 5 times 10 to the power minus 2, plus angular momentum for the bar is 0. That should equal to over here it's going to be minus 0.1, but we don't know the speed, and we have same distance. This is also 0.1, and plus I0 will be so what's the formula for I0 or IO at that point is at the edge is 1/3 ml square. So that's for IO. So 1/3 m is 1 kilogram, L is 0.2 square, so 0.2 square. So everything is like 10 minus 2. So this is also 10 minus 2, and over here is also 10 minus 2. So we just say multiply, or you can multiply by 10 to minus 2 everybody, and so you will start to get 5 equals to minus v plus 4/3. So this is one equation. This is omega is missing here, 4/3 omega. So okay, so this is equation 1. That's good. And then kinetic energy conservation. Kinetic conservation will be almost the same kind of stuff, right? So let's work it out over here. It's going to be half times 0.1 times 5 square plus 0. I'm just leaving out the units for the sake of saving time. And instead of minus, kinetic is always positive. So half 0.1 v square plus half I0 is going to be 1/3 ml square. So that's a times 1/3 and 4 times 10 to the minus 2 omega square. So that's and you can see here that half, all you probably know this half almost always cancels out in the collision elastic collision problems. And so we have there's 10 to the minus 2 here, so but this one is 10 to the minus 1. So if again I do 10 to the minus 2 multiply with 10 to the minus 2, then this becomes sorry, multiply by 10 minus 2 just to make this guy 2.5 equals to, this is going to be 10 v square plus, that kills that, 4/3 omega square. I just noticed here some mistakes. Okay, I have to multiply 10 plus 2 to kill 10 to the minus 2, right? So over here I have to multiply 10 by 2. So this is going to be 250, 2500, because 250. It's going to be 250, and this will be okay, and this will be okay. So equation number 2, equation 2 will be 250 equals to 10 v square plus 4/3 omega square. Now we are going to have to solve for v omega, so you can do a number of different ways, right? This is omega and this is omega square, so you can't just subtract and get rid of it. So let's try to do from 1, you say v is, bring the v this side, 5 on the other side, minus 5 plus 4/3 omega square. So that will mean I need 10 v square. 10 v square will be 10 times minus 5 plus 4/3 omega. So that will mean 10 v square is equal to 10 times a square plus b square, right? So 25 minus 40 over 3 omega plus 16 over 9 omega square. And so I plug in there, you can see 250 already cancelled that side, right? So you have a 250 equals to 250 minus 400 over 3 omega plus 160 over 9 omega square plus 4/3 omega square. Okay, this will cancel out, and then omega will factor, so 160 over 9 plus 4/3 omega minus 400 over 3 equal to 0. So there are two situations. One is either omega equal to 0, which is not the case, it's going to rotate, or omega is this divided by that. So our omega equals to 400 over 3, where you can see if you make over 9, so 160 plus 12 is 172 over 9, and we need to simplify it. Okay, so I went ahead and did some calculation quickly, and look, so over here I used a calculator. I'm not sure if the calculator is allowed, but a simple calculator will do, or just you can do multiply, divide until you get to some rough calculation. And you can see in the answer, this one of the choices is 690, 6.98 and 6.80. Even if you got approximately, then you get one of these. So this is the one I got. So A looks like the answer. So it looks like A is the answer. Now check B part. Let's put this in over here or over here to get a V. So V equals minus 5 plus 4/3. Omega is 300 over 43. So this is 100, and so it's 400 over 43. So this is minus 5 plus 443. And you can see, even if you didn't have a calculator at this stage, you could just make this guy 44 or something like that. And so this will be minus 5 plus like 100 or 1 over 11, and it's like 9 point something. And so if you have a 9 point something, so 100, so you have a 9, so like 9.1. So this is like a minus 5 plus 9.1, which is 4.1. So it looks like you have a 4.1, but you got to do it a little more accurately. And when I do it accurately, if I do it more accurately, let me plug in calculator. So I get a minus 5 plus 400 over 43. Let me just do the calculator. So when I do the more accurately this calculator, I get 9.3, and that just makes it 4.3, and which is A. Okay, so that's a pretty neat problem. Actually, this is not very advanced problem because just a couple of steps, and I don't think it's a discriminatory. Probably every student got this problem because this is a standard problem. All right. Okay, so in the next video, I'm going to record a solution to this problem. Okay, so till then, take care. Bye.